Hello and welcome back to my channel. Today on the bench I have a switching mode power supply. Apparently it's broken, so we're gonna take a look and see if we can fix it. Now first thing first, usual disclaimer, power supplies are dangerous, there are lethal voltages inside. This is not a tutorial, so if you don't know what you're doing, just don't work with power supplies. Now actually I seldom works on power supplies. The reason is that usually you can buy another one, you don't want to invest time on them, it's cheaper to buy them new, and also most of the time they're really crammed inside. It's impossible to probe things, to access components, so sometimes it's a difficult exercise. But this is quite nice and I'd like to save it, even though it's really nothing special. It's about 20 years old, so it's pretty old, but it's kind of powerful for the age. It's multi-output, so it's got 5 volts, 15 volts and minus 15 volts. This is for a sound device, so you got the plus and minus 15 volts. I think it's mostly used for the balanced outputs, which is running on plus and minus 15. At 5 volts, this power supply can deliver up to 15 amps, which is not bad for such an old power supply. It's only 5 amps at 15 volts and 2 amps and minus 15 volts. Now, if I remember right, this is supposed to be a medical grade power supply, so that's supposed to be a bit more reliable with more clean output than, like the average box standard power supply that you can buy. Now, I'm not entirely sure what's wrong with this power supply, so we're gonna test it in a second, but first, let me thank PCBWay, the sponsor of this video, and now let's go ahead and test this unit and see what's wrong with it. Now the layout of this power supply is pretty simple. I'm in the UK, so we use 240 volts and 50 Hz. That's coming through here, through this connector here. Here on the left hand side is the primary, on the right hand side is the secondary. We got some interference filtering here, the bridge rectifier here, the main bull capacitor and the main switching IC, which is controlling the whole power supply. Now this switching IC supports power factor correction, which I understand is done in this section here, and the main switching transistors, so I guess the MOSFETs, are in this area here on this heatsink here, and this is, let's call it the main transformer. I understand it's not exactly a transformer, but for the purpose of this video we can call it the main transformer. Out of this transformer we have several inductors which are smoothing the switched energy coming out of the transformer itself. We got some rectification diodes, and then we have some smoothing capacitors, some adjustment for the voltages, and the main connector outputs with 5 volts, 15 volts, and minus 15 volts. Now the advantage of a switching mode power supply is the size. Now to get this amount of power and also this amount of voltages with a regular power supply, a linear power supply, you would need a massive transformer. The reason is that the linear transformer runs with mains, which means it runs at 50 Hz, which is what we have here in the UK. It would be 60 Hz in the US or somewhere else, but we're still pretty much low frequency. A switching mode power supply runs at much higher frequencies. It depends on the power supply, but we can say something around 150 kilohertz, and that, for reasons I don't really know to be honest, makes the components much smaller. The main transformer doesn't have to be as big as the linear brother. Now the way switching mode power supply works is very simple. We get AC from mains, we rectify straight away and we go through a capacitor, so we end up with about 340 volts DC. This DC voltage is being fed to the MOSFETs. The MOSFET are being driven by the controller. The controller is outputting a square wave. It's a switched signal, and that instructs the MOSFETs to turn on and off that 340 volts DC, which goes through this very small transformer. The switched output is being rectified and smoothed by the inductors, diodes and capacitors to provide a DC output. Now, if I'm not mistaken, the switching frequency of the controller is always the same. Let's say 150 kilohertz. I don't know exactly this one, but what can change is the duty cycle, which is for how long that 340 volts is switched on per cycle. And by changing that duty cycle, you're actually changing the voltage that you have at the output of the power supply. Now, like any other good power supply, this power supply also features some feedback. So the 5 volts and 15 volts line are being monitored, and a feedback signal is being routed back to the controller through these two optocoupler, which assure complete electrical separation between primary and secondary. So the controller knows how to change the duty cycle to make sure that the 5 volts and 15 volts are stable in voltage, regardless of how much load or current is being drawn by the unit. Actually, this power supply has a nice feature. This black connector here is the remote sensor. The idea is that you might have like a long lumen cable going to your device, and while you have 5.0 volts here at the output, you might not have 5.0 volts at the end or wherever you want to make sure that you actually have 5 volts. So to compensate for that, you can run a thin cable from where you actually want 5 volts and run it back to the power supply and send the signal back to the PCB. Now, because the cable is very thin and there's no load basically involved, it's just a monitoring cable, there won't be any voltage drop introduced by the cable itself, so the controller will be able to adjust the operation of the power supply itself, the duty cycle, to make sure that at the end of the looming cable there is 5 volts and not necessarily at the connector, which might not be an exact representation of what happens at the where the cable is actually connected on the motherboard, for example. So enough me talking, I would say let's plug this thing up and see what's wrong with it, because I'm not sure about that. Alright, first thing first, I want to check the fuse, because what happens usually with this power supplies is one of the main MOSFETs, switching MOSFETs, shorts, and that usually blows the fuse. And if the fuse is blown, at that point it means that probably we need to look for a short somewhere. So let's have a look. Okay, so the fuse is not blown, which is good, and I would say means there's nothing catastrophic happened to at least to the main section, to the primary section. I would say at this point, because I have a current limiter, so nothing horrible should happen. Maybe we can power it up and see what happens. Maybe it's working. I was told it's not working, but I don't know. Okay, ready to power up. As I said, I've got a current limiter, so if anything is shorted, I should first of all see that straight away from the light bulbs. They will start shining at full brightness, and secondly, even if something happens, it shouldn't be anything too catastrophic. But anyways, let's power up. I'm monitoring the 5 volts line at the moment, so if something is coming up, we should see that on the fluke. And let's power up in 3, 2, 1, go. There's absolutely nothing coming out of it. My current limiter is reading 3.6 watts, which probably happens even if nothing is connected to it. Let's check the 15 volts. Absolutely nothing. And let's check the minus 15 volts. And there's absolutely nothing. Well, at this point, it could be a little bit of everything. The first thing I want to do is to make sure that we actually have rectified DC coming out of the bridge rectifier. Now, usually bridge rectifier end up in a short, and that will take down the fuse, of course. But you never know. I want to make sure that, like at the main bool capacitor, we have our 340 volts. So let's check that. Okay, I've removed the power supply from its cage for a moment, and this is the main bool capacitor. Again, as I said, this is very dangerous, so don't do this at home unless you really know what you're doing. So let's give power to the power supply. 3, 2, 1, go. Okay, and now we can check what kind of voltage we're getting here. And we're getting 340 volts DC, which means the bridge rectifier is working, and we definitely get the mains power that we are expecting inside the power supply, so that's not our problem. Right, I was doing some testing off camera, and suddenly the power supply started working. I got 5.2 volts out of the 5 volts line, and let's check the other voltages here. Yeah, we got 15 volts, and we have minus 15. And we also have minus 15. So this started working for whatever reason. It started up in a jerky way, if I can say that right. So it started like it was jumping between voltages, and then eventually stabilized at 5.2 volts. That is quite interesting. I'm wondering whether I might be able to trigger this behavior with hot air and cold spray. Let's give it a go. So I got my bottle of cold spray here. Let's try and turn it on and see if it still works. Turn on now, and it's not working. And I'm assuming it will start working in a second, maybe. I've got my hot air. Oh, there it is. It's kind of starting. And there it is. It's jumping a bit. Oh, that's cool. So let me try and warm this up a bit. Yeah, it starts and it goes to 5 volts straight away. Now what I want to do is I'll turn it off, and I'm going to cool down this IC a bit. Let's turn it on again. 3, 2, 1, go. and it's dead. Now let me switch it off, warm it up. Let's turn it on, 3, 2, 1, go. And it works more or less straight away. So let's do a final test. I'm turning it off now. I'm gonna cool it down a bit. And on now. And it's not working. And I guess it's still on now, so I'll be careful. If I warm this up, it turns on as soon as it's switched on. So yeah, it looks like the IC might have failed internally, and the cooling it down and warming it up is basically probably restoring temporarily whatever is broken internally. It could be a wire bond which is slightly detached, and with the expansion and contraction when you warm up and cool down the IC, you get this temporary fix that fixes the IC, and then it dies again when it cools down. Perfect. Now, I'd like to take a look with the oscilloscope, and bear in mind I'm using my differential probe here. The reason is that if you are using a standard probe, the ground lead of the standard probe is actually grounded, but the ground that is listed on that IC is not mains ground. The differential probe allows me to do whatever I want. It's like a multimeter. You can poke wherever you want. It's basically reading the differential between the 2 points. So I have wired my ground lead here, my black lead actually, it's not ground, to the ground pin of the IC, which happens to be copied at the top of that resistor. I just buzzed it with my multimeter. Okay, so it's like my black lead is connected to the ground. And the first thing I want to try is to make sure that the IC is getting voltage, because the way the IC is getting voltage when it's still not switching is kind of unique of switching mode power supplies. There's a small capacitor involved, which might be bad, and it basically gets voltage from the rectified mains, and eventually when the power supply starts switching, it powers up itself. But until that happens, it gets mains from voltage with the help of a small capacitor, which I believe is either this one or maybe this one. There's also a very, very small one here. There's only 4 capacitors actually on the primary. So it could be one of those capacitors which is failing and the IC is not getting voltage, and that could be why it's not starting. And when I'm warming up the IC, actually I'm warming up a bit the whole area. I'm also warming up the capacitor, and maybe the capacitor is coming back to life and powers up the IC. That could be a possibility. Now I'm going to probe the VCC of the controller IC, and I'm expecting to see something about 15 volts-ish, and it will ramp kind of slowly. That's normal because you have the small capacitor helping out with that voltage. That's also why switching mode power supply take like about a second to actually output voltage, and I've got the fluke connected to the 5 volts output, so we know while we are probing VCC looks fine, but we haven't got an output, then we know that that's not our problem. Okay, I'm on VCC now, 3, 2, 1, go. Yes, it's going up. And yeah, that's totally fine. It's 16 volts and we haven't got an output. Turn it off. So that is telling me that the IC is getting voltage and probably the startup circuitry of the power supply is working fine. Now the next thing I want to check is the iSense. iSense is the sensor for the controller. It's sensing any overvoltage and overcurrent from the secondary. So if the secondary detects an issue because there's a short or it's been the power supply has been driven too hard, it will report it back to the main controller. The main controller will turn off immediately if the iSense pin goes over 1 volt. So it could be our case here that we might have an issue on the secondary. Maybe the circuitry is broken and it's sending 1 volt all the time, even though there's nothing happening, or maybe there's not a short, or maybe there is a short, and that's why the whole power supply doesn't work. The bottom line, the iSense pin has to be less than 1 volt for the controller to work. So let's check that. I'm on iSense right now, 3, 2, 1, go. And no, it's only a few millivolts and nothing happens. And I guess, that's kind of expected. There's no output, so there's nothing being fed back. But definitely this is not what's stopping the controller. Now the other pin I want to check is VREF, and I understand that that's 7.5 volts, and that's being generated by the IC through VCC. So if VCC is on, we must have 7.5 volts at the VREF pin. So let's check that. 3, 2, 1, go. And we don't... Oh, it's switching. Peak to peak says 8.8, so that's probably our 7 something volts. But it's weird. It's not supposed to be switching, I understand. And again, I understand that this is the generated internally by the IC itself when VCC is happening. So yeah, that kind of starts pointing at the IC itself. Soft start is another pin that I want to check, and I also understand that this is being generated by the IC itself, and I think it's just going through one of these two tantalum capacitors, and probably then it's going to ground. So we might want to check that one of those capacitors is not going to ground, because that might short soft start to ground, causing potentially this very problem. 3, 2, 1, go. And there's nothing on pin 5. It's a little something, but it's basically nothing. Now finally, let's check that we actually don't have a switching coming out of the controller. We don't have an output of the power supply, and I'm expecting not to have a switching signal from the controller itself, which would explain why we don't have an output. So let's check that. 3, 2, 1, go. And no, we haven't got absolutely anything. What I want to do now is to warm up the IC, wait until the whole power supply wakes up, and then we go ahead and recheck those pins and see what they read when everything seems to be working fine. Okay, the IC is warmed up, and I'm probing the switched output. So let's power up and see what we're getting. 3, 2, 1, go. Still nothing. That's interesting. I've warmed up the IC. Let's turn it on and see whether it works now. 3, 2, 1, go. Oh yes, there it is. It's turned it on. There we go. And we got switching at 132 kilohertz. Perfect. So that's what I'm expecting. Let's check all the other pins. This is my 7.5 volts VREF. As you can see, it's totally stable and it's reading 7.5. This is iSense, which is still reading nothing. It's reading 200 millivolts, I can see. But that makes sense. There's absolutely nothing using the power supply. So it makes sense that the iSense is actually 0 or very close to 0. And this is soft start, which is reading 8.2 volts, which is also telling me there's no, at least permanent, short to ground, though it could be one of those capacitors that shorts when it's cold. Now I've got a little setup here that I'd like to show you something, and actually something else is happening. So I've connected my digital load, and it's actually off right now, so it's not applying any load whatsoever. And I went to power on the power supply. I'm monitoring the switched output of the controller, and you can see what the problem is. The voltage is unstable, and it looks like the controller IC is having trouble maintaining that switched waveform, and it's actually changing in amplitude, which shouldn't really happen. Anyways, I believe that if I warm up the IC a bit more, it will probably stop doing that. Actually, yeah, it's still doing it. There you go, I warmed up the IC and it stopped completely. Amazing. So that's real time our problem. What I'd like to show you now is that duty cycle that we were talking about a few moments ago. I got here my digital load is right now is switched off, so it's not doing anything. And what I'm going to do, I'm going to turn it on to 5 amps in a second. And what I'm expecting to see on the oscilloscope is the frequency of 132 kilohertz will stay the same, but the duty cycle will increase to compensate for the extra load. So I'll turn the 5 amps load in 3, 2, 1, go. Yes, and you can see that the switching frequency is unchanged, 132 kilohertz, but the duty cycle has increased to compensate for the voltage drop that would have happened if the duty cycle hadn't been increased. So that's a feedback coming back to the controller, says, hey, the voltage is going down here, you need to increase the duty cycle. That happens, and I'm still getting 5.1 volts at the output with no voltage drop. So as you can see, this power supply seems to be working totally fine once it has been warmed up. And if I cool it down, I'm sure it will stop working again, but we've done it already. So I think we have a faulty controller IC. So I'll go ahead, order a replacement, and then we'll replace it, and hopefully that will fix our problem. Now, before we begin, let me thank one of my viewers, DJ Marek78. He is my go-to person when it comes to power supply issues and repairs. I couldn't have made this video without his help, so thank you very much, DJ Marek78. Take a look at DJ Marek's YouTube channel. He's not in English, but I'm sure you'll find it entertaining. It's obviously about electronics repairs and the things that we all like if we are watching this video. I was struggling a bit thinking how can PCBWay help when it comes to a power supply. Then I had a look online and I found a whole section of projects on PCBWay.com related to power supplies. There are pages of projects related to power supplies, from Amiga, adapters, Commodore 64 or even more modern stuff. So anything that you might need for your power supply or a project of your choice, well, PCBWay is your stop. You know that I've been using PCBWay for my projects for quite some time. I can't complain about the quality of the products, the customer service is top-notch, and using the service is incredibly easy. All you need to find is the Gerber file of the project of your choice, upload it on PCBWay.com, and the website is more or less automatic. You might want to change the color of the PCB, choose a postal service, and the PCB will be delivered at your place. If you need something 3D printed, well, PCBWay can help you with that. I've got some 3D printed items coming to these channels and hopefully I can show them to you very soon. For all your project needs, take a look at PCBWay.com. The link is also down below in the description. And let me thank PCBWay for sponsoring my channels, my videos. Their help makes these videos possible. So thank you very much, PCBWay. Now let's continue with this power supply. A few days have passed and I've got a delivery from Aliexpress. Now, these ICs are what I asked, though the label on top of the ICs, they're all different between each other. So I'm hoping it's just like different batches and they're not fake. They don't seem like they're being sanded over. One thing I can do, I have a little cotton swab here with some alcohol on it. I can try and see if the marking comes off. No, it seems to be okay. There's a little dirt coming off, but the marking seems to be good. So hopefully they just belong to different batches. Now let me remove this board from this cage, and we'll start swapping it. I'll start obviously removing this faulty IC. Hopefully it's faulty IC. Now we'll do some checks before installing this one, and then we'll test the power supply. And finger crossed, it will work. Oh, and by the way, did you know now I have a second channel? It's called Tony259. I'm sure you'll find something interesting there if you like this kind of things. So go and take a look at Tony259 and please don't forget to subscribe. I only have like 800 subscribers at the moment. So the more the better will help me with the algorithm. Alright, now the IC is out, I'd like to do a quick check of the passive components. You know, just make sure they're not dead shorts and all resistors are reading something basically, they're not open. So I've marked the ground pin for the IC with a little green dot, and I'm gonna poke around with my multimeter either in diode mode or continuity resistance mode, and you know, looking for things which are out of the ordinary. For example, there are 5 small capacitors here and they're all connected to the IC on one side. On the other side, they're all connected to ground. So by checking the right hand side, which is where the chip would go, I can just make sure there's nothing dead short, which would probably prevent the IC from working. Only the top one is reading something, but if I'm checking with resistance mode, it's actually 67 ohm, which is not a dead short, and that's totally normal to see between probably like VCC and ground or something like that. And all the resistors are reading something but this one, which is doing these weird things. I'm assuming there's a capacitor somewhere on the circuit, and that's, my multimeter doesn't like it, but there is something happening, which is probably telling me that the resistor is totally fine. Now, I think someone has been here before, because I can see there's an electrolytic capacitor, which probably was either removed or reflowed, and I can definitely see that someone has been here. I probably see something here, and maybe something here at the bridge rectifier. I don't know. I mean, these two might be factory modification, no modification, but little touch-ups. But that's definitely not a factory thing, and I'm not sure why someone might have gone ahead and just replaced that capacitor. Anyways, I don't know. The other thing is, I might have found some component damage. Let me show you. And yes, I can see there's a small capacitor, which seems to be broken. I'll have to put it under the microscope to show you properly. And yes, the capacitor is definitely broken. I'm not sure it was me. I will have to go back on the footage and see whether when I removed the IC, I accidentally kind of applied any stress on that component, and maybe I broke it. I definitely didn't touch the back where the soldering joint is, but that's definitely basically split in half. Now, that's definitely not the end of the world. I can order a replacement. Meanwhile, I guess I'll borrow one from an identical unit that I can use for parts, so we can continue today with this repair. And this is the capacitor in question, which indeed is broken. As you can see, it says 104 on it, which means 10 with 4 extra zeros on it. So that means it's a 0.1 microfarad. Now, doesn't say anything about voltage. Let me check into my stash. I might actually have a replacement for that. Now, I found some 104 capacitors in my stash, and it's rated 50 volts. Now, I think it's going to be totally fine, but I want to be 100% sure. So I've got out a working power supply. It's identical to the one that we are repairing, and I've marked this component here, which is the capacitor that broke or exploded on the other power supply. Now, my multimeter has one of the leads connected to ground, and one of the leads of this capacitor is directly connected to ground. Got 1 ohm here. The other one is directly connected to the VREF of the controlling IC. And if I understand right, it should be 7.5 volts. But I want to double check that. So I've got my multimeter in DC mode, and I'm going to power up this thing with the probe on the energized leg of the capacitor to check the voltage. In 3, 2, 1, go. And yes, we're reading 7.45 volts DC. That's actually coming from the IC. So 50 volts is going to be totally fine, and we can use that component. Alright, the IC is back in place. I got my fluke connected to the 5 volts output, so if this works, we should see some voltage on the fluke, and I've got my oscilloscope connected to the switching output of the IC. I'm really curious, will it work? Well, we have one way to find it out. In 3, 2, 1, go. Yes, 5.2 volts, and the switching is switching, so it was definitely the IC, and unless it was that, let me switch it off, unless it was that capacitor, I need to go back on the footage and see when that got damaged, if it was me or if it was damaged before. Now, I cannot use this power supply for too long outside of its cage, because the cage is actually acting as a heatsink for all these diodes and regulators, and the PFC, everything is connected to the cage. So let me quickly check the other two voltages. A few seconds is totally going to be fine, and then I'll put it back into its cage, and we can do a proper test. This should be 15 volts, 3, 2, 1, go. This should be 15 volts, 3, 2, 1, go. And we do have 15 volts, amazing. And finally, we should have minus 15 volts on that pin. 3, 2, 1, go. And we got minus 15 volts. So that seems to be working. And again, we can run some proper stress test. Now, before I go ahead with that, I think I'd like to swap most of the capacitors on this power supply. I know it's totally debatable. It's just this power supply is about 20 years old, and it belongs to a device which is on 24/7. So as part of the repair, I have agreed with the owner that I would also swap the capacitors, at least the big ones on the secondary, which are going to be reading totally fine. At least that's my experience with these power supplies. And they're good quality, a Nichicon, 105 degrees. So it doesn't have to be done to fix the power supply, but the idea is this hopefully is going to be lasting another 10 or 15 years, and I feel it's like a good idea to just, as part of the repair, just replace all the capacitors. But I know it's totally debatable, and I don't normally replace things just for the sake of doing it. So I got some matching high quality, mostly Panasonic 105 degrees capacitors. Let's swap this out, and then we can put it back into the cage and do some proper tests. Alright, the power supply is back in the frame. I got my digital load connected to the 5 volts line, which is the most powerful one. It can output up to 15 amps, and 15 volts and minus 15 volts are connected to a dummy load, which is outside of the frame. You can't really see it, but it's there just to give a little bit of load on the other rails as well. Now, I don't think my wiring here can withstand 15 amps, definitely not for a long time, but I guess we can give it a go up to, I don't know, 10 amps, so, we'll see how it works. And then, to be honest, I will install this into the equipment where it belongs and let it run for like a few days, 24/7, make sure that everything runs totally fine. You will be able to see the 5 volts reading on the digital load itself, even though I guess there will be quite a lot of voltage drop because of the wiring, and the 15 volts will be here on the fluke. So let's power up, 3, 2, 1, go. We got 15 volts here, and the dummy load is reading 5.12. These are adjustable, by the way, so we can actually check and make sure the feedback, the adjustable feedback is working fine. You can see the 5 volts is going down to 4.4 volts up to 5.5. I can actually hear a whining noise coming from the power supply. I hope it's normal. So let's turn it down to 5.1, and the 15 volts, it's in here, it goes up to 15.22 and down to 13.38. Well, the power supply is working. Let's turn on our digital load here. We got 5 amps and we got 24 watts. And so far the voltage obviously has dropped to 4.8 because of the wiring. We are at 10 amps. For 45 watts, so it's not too much. Again, it's an old power supply. Everything seems to be working fine. 15 volts is still stable at 14.9, and everything seems to be working totally fine. And the power supply reached 15 amps, no problem. I can feel my wiring here are getting a bit warm, but everything is fine. 15 volts is 15 volts. Obviously, again, 5 volts is decreasing a lot. I should probably make a better testing environment here with bigger wires, but the power supply is working. All I need to do now is to test it for 48 hours and make sure that everything works fine as expected. So all in all, I would say it's an interesting fault and maybe a simple one. The controller is kind of easy to diagnose. It's pretty big and accessible. We got this open area here where you can stick your probes and do checks. No switching, so obviously, you start blaming the controller first. And it's good to know because I have a few of these power supplies and I start seeing what are the most common faults. So if it happens again, obviously, I more or less know straight off the bat that is the controller. I have a few spares, and I hope that these spares actually work. They're so weird that they have these little different labels. For now, I've tried 2 on 2 identical power supplies, and they work totally fine. So I hope you enjoyed this video. I really have, despite being a simple repair. It's another device saved from the landfill or for recycling. It's nice that we've given it a second life, and hopefully, this device can work for another 10-15 years, who knows. So if you have enjoyed the video as I have, I'd appreciate a thumb up down below, and also consider subscribing to this channel if you like this kind of things. Don't forget, I have a second channel, Tony259, and I'm also on Patreon, where you can support my work. There's a free tier on Patreon, so you have no excuses, but if you really don't want to join me on Patreon, and the link on Patreon is down below in the description, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to join Patreon or buy me a coffee or anything, just watching this video is totally fine. Maybe a thumb up, maybe a subscription, a comment, that would be absolutely fantastic, and I do appreciate your time. That's it for today. I hope you have a great day, and I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye bye.